Welcome to this video on PySpark, where we'll explore one of the most crucial steps in building efficient data processing pipelines, checkpointing a data frame. If you've ever worked with large datasets in Spark, you know how important it is to save intermediate results, to avoid recomputation, and reduce overall processing time. In this video, we'll dive into the world of PySpark checkpointing, explaining what it is, why you need it, and most importantly, how to do it correctly. Whether you're a data scientist, engineer, or simply someone interested in big data processing, this topic is essential for anyone working with Spark. So let's get started. So, what exactly is checkpointing in PySpark in simple terms? Checkpointing is the process of saving a data frame to a reliable storage system, such as HDFS or S3, at specific points during your data processing pipeline. This allows you to recover from failures and avoid recomputing expensive operations. Now, let's break down the concept into smaller parts. Imagine you're working on a complex ETL, extract, transform, load, pipeline, involving multiple joins, aggregations, and filtering operations. Without checkpointing, if your Spark job fails at any point, you'll need to restart from the beginning, which can be time-consuming and resource-intensive. Checkpointing helps mitigate this issue by saving intermediate results to disk, allowing you to resume processing from a specific point in case of failure. But how do you properly checkpoint a data frame in PySpark? The answer lies in understanding the different types of checkpointing available in Spark: local checkpointing and reliable checkpointing. Local checkpointing saves data to the executor's local disk, whereas reliable checkpointing writes data to a distributed file system like HDFS. When deciding which type of checkpointing to use, consider factors such as data size, processing time, and fault tolerance requirements. For instance, if you're working with small datasets and can afford to recompute lost work, local checkpointing might be sufficient. However, for larger scale applications or those requiring high availability, reliable checkpointing is the way to go. Now, let's walk through an example to illustrate this concept further. Suppose we have a data frame DDF that represents user interaction data, and we want to perform several transformations on it before saving the final result. Python hash. This is just a sample Python code, snippet for illustration purposes only. From PySpark SQL, import Spark session, Spark session, builder.appnum, checkpointing example, dash.day, getter create, df spark.read, parquet, user interaction. Hash perform several transformations. Def transformed, df filter, df arch 18 to group B, country, dot, count, hash, checkpoint, the transformed data frame, checkpointed au df transformed, dot checkpoint, legend. In this example, we create a Spark session and written our user interaction data from Parquet files. After applying several transformations to the data, we checkpoint the resulting data frame using the checkpoint method. To summarize, here are the key points to remember when working with PySpark checkpointing. Checkpointing is a critical step in building efficient data processing pipelines. There are two types of checkpointing: local and reliable. Choose the right type of checkpointing based on factors such as data size, processing time, and fault tolerance requirements. That's it for today's video on how to properly checkpoint a data frame in PySpark. We hope you now have a better understanding of this essential concept in Spark development. If you have any questions or topics you'd like us to cover next, please leave them in the comments below. Don't forget to like this video and subscribe to our channel for more content on big data processing, machine learning, and programming. Thanks for watching.